So, good morning students. Today we are discussing the IIT-JEE NEET Foundation. So, the topic is projectiles. So, projectiles, if a body projected with certain angle with the horizontal is called projectile. See, we see regularly in the games like soccer, football, those games a ball is kicked from the ground and reaches the target, something like some other point. It's like a projectile. The body traveled here, the projectile. The trajectory of a projectile is parabola. So basically projectile is the topic which comes under the mechanics in the two-dimensional motion. The two-dimensional motion, see, when a body changes its position with respect to surroundings and time, then it is said to be a motion. If the body changes along with x-axis and y-axis, then we will call it as a two-dimensional motion. Projectile is an example of the two-dimensional motion. So there are different types of projectiles: projectile, oblique projectile, horizontal projectile. So if a body projected less than 90 degrees with the horizontal, we will call it as a oblique projectile. So the oblique projectile, the applications of oblique projectiles, like we are observing recently there is a Ukraine-Russia war. So the missiles are fired, ballistic missiles are fired from the land of Ukraine or land of Russia. It reaches to the opposite enemy targets and hitting the targets. So with specifically, so these type of missiles and ballistic bombers executes a path that is called projectile. So here the topics we are covering in the projectile is the trajectory of a projectile is parabola. The trajectory of a projectile is parabola, horizontal range, maximum height, time of flight, etc. So those are the topics we are going to discuss. See, first of all, see, the trajectory of a projectile is parabola. How to derive this? To derive this, first of all, oblique projectile is the object which is to be launched into the air with certain angle with the horizontal. See, there is certain angle which is not directly vertical, which is not directly horizontal. It's a some inclined, so with less than 90 degrees if the body is projected. So that we will call it as a projectile. The path of a projectile, the path which is traced by the projectile is called parabola. See, coming to the important points in the oblique projectile, the important points, the motion of the oblique projectile. So we have to broken down into two parts. The first part is along x-axis, horizontal, and another one is along vertical, that is y-axis. X-axis, horizontal, the x-axis components, like, see, if you take the components like, see the components, x-axis components, if you take x-axis component, horizontal components, like initial velocity that is ux, initial velocity along x-axis ux, and if see there is acceleration along x-axis is ax, and final velocity along x-axis is vx, displacement along x-axis is sx. So these are the horizontal components. The velocity is the vector quantity. The velocity resolved into two components. One component is along horizontal. See, horizontal is x-axis and vertical is y-axis. The y-axis components, if you take the y-axis components, the vertical component of a velocity, initial velocity uy. See, acceleration along y-axis is ay, and vertical final velocity, so vy, and displacement along vertical, that is sy. See, these are the vertical components. Horizontal components are ux, ax, and so vx and other sx. Similarly, vertical components Vy, Ay, V, so Sy, etc. See, and by using the equation of kinematics, the equation of kinematics is, see, V is equal to U plus At. So that's equation can be written as Vx is equal to Ux plus Ax into T. Similarly, displacement Sx is equal to Ux into T plus of Ax into T square. So Vx square minus Ux square is equal to 2Ax Sx. See, like this you can resolve the components, and the equations also can be written two sets of equation. One set of equation, see, that is horizontal component equations. Similarly, vertical equations. The vertical equations are, see, Vy is equal to Uy plus Ay into T. Sy is equal to Uy into T plus of Ay into T square. And Vy square minus Uy square is equal to 2Ay Sy. See, these are the vertical component equations. So by using all these equations, like two dimensional, one dimension is along horizontal and another dimension is along vertical. So with the two sets of equations, we can prove the trajectory of a projectile is parabola. The trajectory of a projectile is parabola. So that is only here it is explained. The motion of an oblique projectile broken down into two parts. See, that is horizontal motion and vertical motion. Horizontal motion, see, the important points in the oblique projectile. Along the horizontal motion, the acceleration along x-axis should be taken as 0. The acceleration along x-axis should be taken as 0. This is the very important point you have to remember. And similarly, and acceleration along y-axis should be taken as minus g. Acceleration along y-axis should be taken as minus g. G is nothing but acceleration due to gravity. So by assumption, so we can have the equations. So here the initial velocity, so it is determined by the initial velocity of the object. Vertical motion, the hand, the influenced by the force of gravity. In vertical motion under the influence. That's why acceleration along y-axis is minus g. It's a gravity. Acceleration along x-axis is 0. See, coming to the next slide. The basic rules of the projectile. These are the basic rules. The rules are, an object travels through the air, it experiences force of gravity. Object travels through the air, it experiences force of gravity, and it is the body is there in the air. So when it is in the air, the object having certain, okay, so air resistance also. We are neglecting the air resistance here. So after neglecting the air resistance, we are resolving all the components like velocity and see other components. We are resolving the components into two, horizontal and vertical. So that we are considering. So once if it is resolved, then we can derive the equation. The equations are, the trajectory of an oblique projectile depends upon the several factors. That is angle of launch, initial velocity, mass of object, maximum height, etc. So these equations we have to, okay, so derive it. In the process of derivation, see, let us take the derivation is simple here. If a body is projected, with certain angle like this, so the initial velocity resolves into two components. One component is along x-axis, another will be along vertical. So now if you take the displacement along x-axis, for example, there is certain distance is travelled here. See, if you take that certain distance, the distance is this. See, along x-axis is x and along y-axis is y. So the distance is nothing but, according to the equation of kinematics, distance or displacement x is equal to ux into t plus of ax into t square. Ux into t plus of ax into t square. But ax value is 0, hence this term is neglected. So x is equal to ux into t. This is the ux is nothing but the initial component. Okay, the initial velocity component ux is u cos theta. So that's why you can write here t is equal to x by u cos theta. T is equal to x by u cos theta. Similarly, if you take vertical equation, sy is equal to, that is nothing but y is equal to uy into t plus of ay into t square. Uy into t plus of ay into t square. So uy is nothing but u sin theta, that is vertical component of initial velocity. T is nothing but x by u cos theta. T is equal to x by u cos theta, you can substitute, plus of into ay is minus g into t value, just now we derived it, that is x by u cos theta, x by u cos theta whole square. See, if you derive it here, u get cancelled, so that becomes x tan theta into x sin theta is equal to, sin theta by cos theta is tan theta x minus g x square by 2u square cos square theta, g x square by 2u square cos square theta. So this is the equation. What is this equation? This is the parabolic equation. The parabolic equation is, okay, so that is tan theta x minus g by 2u square cos square theta x square, ax minus bx square. So the trajectory of a projectile is parabola. You can derive simply like this. This is the one method of derivation. See here, yeah, coming to the next slide. The oblique projectile have many practical applications. The oblique projectile have practical applications like, see, there is a ballistic missiles, and you can see fired from the guns and cannons, etc. They reaches the target. And the next is something like the soccer goals. If a person hits, it reaches the goal. Okay, so and football goals, etc. All these are all comes under the, okay, oblique projectiles. See, coming to the next slide, the trajectory of a projectile is a parabola. It is proved mathematically. See, let's here the equations are horizontal motion equation, x is equal to v naught x into t. Here instead of ux he has taken, instead of vx, see, he has assumed that, see, ux is equal to v naught x. This is the assumption. Here it is assumed. Okay, similarly uy is equal to v naught y. He assumed like that. That's why the horizontal motion equation is x equal to v naught x into t, and the vertical motion equation is y equal to v naught y into t minus of gt square, v naught y into t of minus gt square. See, coming to the next slide. See, the next slide is here where v naught x and v naught y are the horizontal and vertical components of the initial velocity. Horizontal and vertical component of the initial velocity. We can calculate x and y distances substituting the values. The mathematical proof is by experimentally the evidence what the trajectory of a projectile. Here t is equal to x by u cos theta, that is v naught x, y is equal to v naught y into, see, t value, that is uy into t. T value is, see, this is the t value what we are getting. See, that t value you are supposed to take here. This is the t value. So when you substitute that, so v naught y into x by v naught x minus of g into x by v naught x whole square will come. So now if you observe this equation, y equal to v naught y, okay, so upon v naught x into x minus of g into v naught x square. So this is something similar to y is equal to, see, v naught y is nothing but u sin theta, and v naught x is nothing but u cos theta into, okay, so x minus half into g into, so here v naught x square is nothing but u sin theta. See, v naught x is u sin theta. See, x square, here u sines, actually t is equal to x by u cos theta, t is equal to x by u cos theta of gt square. T value should be substituted here. See, t value is nothing but here x by u cos theta whole square. Similar to this, you are going to get this equation. So that is y equal to tan theta x minus half g x square by u square cos square theta. Both are equal equations. See, here the equation which is in the form of quadratic equation, which is the equation of the parabola. So in this way we can prove the equation of projectile. The oblique projectile is a parabola. See, coming to the next slide, the range of a projectile. What is mean by range? Range is nothing but the maximum distance between initial and final points of a projectile. See, the greatest distance, if you take the greatest distance between initial where the object is launched, where it is reached, so that distance, what we will call it as a, see, range. See, if you take this is a projectile, so this distance is called range. The range is nothing but the greatest distance, the initial to final. The range of a projectile is the horizontal distance it travels before hitting the ground. It is started here and it is reached here. So this the horizontal distance, what we will call range. The range depends upon the initial velocity and angle of projection and acceleration due to gravity. These are the three factors. So now range equal to, how to find out range? Range is nothing but the distance, horizontal distance. So horizontal distance is equal to, see, horizontal velocity into time. The horizontal velocity into time. Of course, horizontal acceleration will be 0, that's why ux into t. What time you should take here? The time is, time of flight should be taken. Time of flight is 2u sin theta by j. So here u sin theta into, so ux is u cos theta, ux is u cos theta. See, here you can take it as u cos theta into 2u sin theta by j, 2u sin theta by j. If you simplify this, u square range becomes, see, u square sin 2 theta, 2 sin theta cos theta. 2 sin theta cos theta is nothing but sin 2 theta, u square sin 2 theta by j. This is the range formula. Range, the units of range is meters, that is u square v naught square sin 2 theta by j. You can derive like this. This is the simple way of deriving the horizontal range. See, coming to the next slide, that is maximum height. So the maximum height is, if a body is projected with certain angle, so let us take here, see, the height at which the final velocity, the final vertical velocity of a body is equal to 0. The height at which the final velocity of a projectile is equal to 0. Here vertical velocity ux will be there, but uy will be 0. Uy will be 0. The final velocity or vy, you can take it as, so will be 0. That maximum height. So horizontal velocity u cos theta exists at the maximum height, but vertical velocity will be 0. So that what we will call height. So the maximum height of a projectile, the highest point reaches, okay, so during the motion where it reaches the highest point, that is called maximum height. So that is vertical height. You can take it as, see, vy square minus uy square is equal to 2ay sy. This is the equation. By using this equation you can solve. Vy will become 0, uy is u sin theta, and 2 into ay is nothing but minus g, and sy is nothing but h. See, u sin theta whole square, that becomes u square sin square theta. So the maximum height equal to, See, maximum height is equal to u square sin square theta by 2g. U square sin square theta by 2g. This is the equation. The maximum height also depends upon, see, the angle of projection, and also depends upon initial velocity, acceleration due to gravity. That's why the equation h is equal to v naught square sin square theta by 2g. You can use this equation so when you want to find out the maximum height. So this is about the maximum height. Coming to the next slide, it is the time of flight. What is time of flight? The time for which body present in the air. Okay, so the time of a projectile which is present in the air from starting to ending, how much time which is there in air, that time is called time of flight. So the time of flight is nothing but time of ascent plus time of descent. Time of ascent plus time of descent. So you can take it as time of flight also depends upon initial velocity, acceleration due to gravity, and so other factors like angle of projection. So the formula is 2u sin theta by g. This is the formula we can use for time of flight. So I hope you understand the video. Thank you very much.